So this is the first topic in Unit 4, features of clouds and grid platforms. In this topic we will discuss regarding various features of grids and clouds. Under this, so we will cover cloud capabilities and platform features. So later traditional features common for grids and clouds, and finally data features and databases, and the last one is programming and runtime support. These are the topics will be covered under this features of cloud and grid platforms. We will see one by one now. In this first topic is cloud capabilities and platform features. So generally any cloud, if it want to get commercially successful, then it need to enhance its capabilities, means it need to add additional services to it. So generally, for example, if we have considered Azure, so currently it is having the features like Azure tables, queues, blobs, database SQL, and web and worker roles. Still it just want to add additional capabilities to it just to become commercially successful. In the same way, AWS Amazon Web Services also, initially it is a infrastructure related cloud only. It provides a infrastructure related services only, but later it has enhanced its capabilities, means it has started giving platform services also, like simple DB, queues, notification, monitoring, content delivery network, relational database, and MapReduce, that is nothing but Hadoop. In the same way, even Google Cloud also. So it doesn't currently offer a broad based cloud services like AWS or Azure, but Google App Engine, it offers a powerful web application development and to enhance the security, privacy, and availability. So we are having some techniques to follow. So some of the points we are having, we need to use virtual clustering to achieve dynamic resource provisioning. So because of the dynamic resource provisioning, we can able to enable the resources utilized at most level. Okay, so that is possible by using the virtual clustering only. So next, stable and persistent data storage. So and we need to use the fastest queries also for the information retrieval of it. Next, we need to use special APIs. So generally in data features and databases, first one is program library. There is so much of work done to get one image library, virtual machine image library, to manage all the images in the virtual machines. Next one is blobs and drives. Generally blobs is a storage concept in Azure cloud. In the same way, S3 is the storage concept in Amazon Web Services, AWS, and along with them they are having service interfaces also. For blobs, service interface is Azure drives, and for S3 the service interface is Elastic Block Store. So and the next one is DPFS, stands for data protection file system. And next, SQL and relational databases. Generally both Amazon and Azure, means Microsoft Azure and AWS, both clouds will offer relational databases. And next we are having table and NoSQL, non-relational databases. Generally it is a NoSQL concept. We are having Azure, it is having Azure table, right? And the same concept in AWS is simple DB. And queuing services will enable the communication between the different processors in clouds. In programming and runtime support, worker and web roles, those are nothing. Worker roles are basically schedulable processors, and they will be automatically launched, means, and which work will be done by which resource. So that is nothing but work scheduling. And web roles and MapReduce, it is especially used in the search engine optimizations, and it is a combination of map and reduce functions. And next one is cloud programming models. Generally each and every cloud have its own programming models. In the same way, Google App Engine and Microsoft Aneka environments represent different programming models. And finally SaaS, it is nothing but software as a service. Generally in each and every clouds we will have the technical features like MapReduce, Bigtable, EC2, S3, Hadoop, AWS, GAE, WebSphere. In addition to them, we need to have some protection features also, which will achieve scalability, security, privacy, and availability. The next topic in this unit is parallel and distributed programming paradigm. So under this we need to cover all these topics, 5 different topics we are having. In parallel computing and programming paradigms, we are having all these concepts. Partitioning, in the sense, here we have 2 different type of partitionings: computation partitioning and data partitioning. So let us see what is meant by computation partitioning. If you are having a big task and that task will not be done by a single system, so that's why the complete work will be divided into small pieces, otherwise small task. That is nothing but computation partitioning. Data partitioning, here the data and small or intermediate data which is required to solve that particular application or task, so that is also divided into small pieces. That is nothing but data partitioning. So next, mapping in the sense, these divided small pieces of data which is required to solve the task, so that will be allocated to the appropriate resources to complete that task. That is nothing but mapping. Next is synchronization. So when this work is done in the distributed systems, here all the systems will be collectively work, right? So there should be a proper synchronization and coordination between the task and resources, because just to avoid the data dependency situation, because dependency is nothing but, for example, if any resource it has waited to get the data from remaining process to complete, so once completing that task only it can able to start this procedure. While they need to share the data to complete their task, definitely there should be a proper communication strategies between the systems. So that is communication. So next, scheduling. If we are having less number of resources than the number of tasks we need to perform, so that's why definitely scheduling process will be needed. And next we are having map reduce, twister and iterative map reduce. So even if they have asked regarding the map reduce for the long answer, we need to write the diagram of map reduce and some matter and definition of it. Regarding map and reduce functions also we need to write, and later, so how we will write the code, map sample code is there. So while we are discussing this one, I have given everything in the running notebook, so that's why once please refer it in for map reduce, twister. And next one is Hadoop library from Apache. So in this main concept we need to discuss is HDFS, means Hadoop distributed file systems. HDFS is a distributed file system inspired by GFS, means Google Files. That means Google Files system that organizes files and stores their data on a distributed computing system. Okay, so this is also like Google File system only, but it is related to Hadoop, especially it will be based on Hadoop. So that's why we are calling it as Hadoop distributed file system. And the next one is Dryad and Drylink. Dryad and Drylink both are the 2 software runtime environments, and these will be developed by the company Microsoft. And the last one is Sazel and Piglatin high-level languages. So Sazel, it is a high-level language and it is especially implemented on the top of Google's MapReduce function. In the same way, Piglatin, so it is developed by the company Yahoo, and it is also implemented on the top of Hadoop. Next, very important topic is programming supports for GIE, AWS and Azure. Please don't confuse. So if they have asked to write about Google App Engine or AWS or Azure, simply that is belongs to 3rd unit concept, means there we need to draw the architectures and we need to write the services in it. And coming to the 4th unit, here we are having programming support for GIE, AWS and Azure, means in each and every specific cloud, what are the special things, special services we are having, that thing we need to highlight and explain here. Okay, so that is nothing but programming support. In programming support of GIE, we need to write about Google File System, Bigtable and Chubby. So next, programming on AWS. In this, the special things we have discussed are Amazon EC2, Elastic Compute Cloud, S3 Simple Storage Service, EBS Elastic Block Service and SimpleDB. And especially, see, generally in the syllabus copy we are having programming support for AWS and Azure in a single topic, but generally they may ask separate also. So if they have asked regarding programming on Azure or programming support for Azure, both are same. At that time we need to draw the diagram and we need to write about SQL Azure and Azure tables. But for example, same like the syllabus copy, if they have asked programming on AWS and Azure, in the sense we need to list out all these 5 topics: Amazon EC2, S3, EBS and SimpleDB, SQL Azure and Azure tables. These diagrams are very important. This is EC2 execution environment and this is S3 execution environment. If they have asked regarding Azure, you need to draw this diagram. This is the last topic in 4th unit. Emerging cloud software environments means latest, upcoming and well famous cloud software environments these are. And here we are having open source Eucalyptus and Nimbus, Open Nebula, Sector or Sphere, OpenStack, Microsoft Aneka Cloud. So if they have asked regarding emerging cloud software environments, now we need to list out all these softwares. Otherwise they may ask a single topic also as the main question. They may ask like, please write about Open Nebula, so like that. So here I will show the diagrams of each and everything. This is Eucalyptus architectural diagram. If they have asked about open source Eucalyptus, please write some theory about it and later diagram. Next, this is a Nimbus cloud infrastructure. Very important, these diagrams, please practice them. And next one is Open Nebula architecture, and these are the main components in Open Nebula software environment. And this is nothing but sector or sphere system architecture. SSL stands for Secure Socket Layer. And this is OpenStack. Finally last one, this one. So this is the architecture of OpenStack.